So here we go. This is something you are going to use multiple times throughout this course as we move forward. You've already seen it once, but you haven't seen it this way. What we're going to do is we are going to take these parabolas, if I go back to the front one, and we are going to work with, instead of standard form, we are going to work with what we call vertex form. And the reason why we call this vertex form is very simple. If we were to graph the parabola, we know that this point right here is called the vertex. Now, when we had standard form, does anybody remember the equation that was used to find the vertex in standard form? Negative b divided by 2a. Excellent. And then you would plug it in. Everybody remember that? What's great about vertex form here is you don't have to do the equation. You can just look at it. So if I just look at it, this is your very front page, guys, in case you're wondering. If you want to know the vertex, it just happens to be the horizontal shift, which is h, and the vertical shift, which is k. That's your vertex. So what's great about vertex form is you can just look at it and see the vertex. All right? So sometimes you see parabolas in that form. We're going to see parabolas and we're going to put them into vertex form. So everybody ready to flip over to this page then? We did letters A and B on Wednesday. So now we follow up with this one in vertex form right here. So I want to put this into vertex form. Now vertex form is y is equal to, or f of x is equal to, a times x minus h quantity squared plus k. And if you notice, it has a completed square. This does not have a completed square. So what we're going to do is we're going to complete the square. And in order to complete the square, I'm going to have the x squared and the minus 6x, and I'm going to put the plus 1 over on that side. Okay, it's on the same side. I'm just going to give myself space. Everybody okay? I just gave myself some space with the plus 1. Everybody good? Okay, so don't focus on the plus 1. Just focus on this guy right here. X squared minus 6x. What should you add to complete the square? Where'd you come up with 9? Good. So 6 divided by 2 is 3. Squared is 9. Any question there? Then this is where you have to focus. This is the new piece. Okay, everybody's good with completing a square, but I can't just add 9, right? If you add 9 to one side, you need to add 9 to the other side. No, don't write that. Don't write that because that's not what we're going to do. If I did add 9 over there, notice there's nothing else to add it to over here. You just have this f of x over here, don't you? Well, if I wanted to move that 9 back over to this side, what would you do with it? You would subtract it. So instead of adding 9 to both sides, we're going to add 9 and subtract 9 from the same side. Does that make sense to everybody? This has to sink into your brain that adding 9 and subtracting 9 from the same side, you have the same equation as what you started with. Good. So then I could just change it now. I've got f of x is equal to, what is x squared minus 6x plus 9? What does that factor to? X minus 3 quantity squared, and then it's, what after that? Minus 8. And now it's in what we call vertex form. So I can just look at this and identify the vertex. What is the horizontal shift? Right? 3. And what's the vertical shift? Down 8. So that's the vertex. And in case I ask this, yes?
So if 3 was, let's say it was x plus 3, just complete hypothetical, would it then be negative 3?
Yes. So if I mark this off, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Did you know that Maddie Vanderside tried to steal my gorilla today? How dare she?
I would too.
Okay.
Honestly.
Okay. Does this parabola go up or down? It goes up because the x squared is positive. That's all right, Paige. Love it when people shout out answers that are incorrect. Shows you have boldness. Okay? Can I ask why you originally said down? Okay, so it's moving down, but the direction is up. Great. Does this have a maximum value or a minimum value? has a minimum value, we would say has a minimum value of -8, that's the smallest value. So if I were to ask, does it have a max or min, it would have a minimum of -8. Yes.
Why is it min not max?
Because it has a smallest point that it gets to. Like it goes all the way up to infinity, right?
Okay,
But it has a smallest.
because if it was maximum, it would go down.
Go down, exactly. Yep.
Okay.
Yep. All right, flip it over. This is a sheet of notes about Vertex in standard form. It's a summary of all of it if you want to use that for kind of a reference or studying, okay? But flip it over to this piece, and now we're going to do these two. So our goal for class is to get done with these two examples. What's different about the second one? What's different about the second one? Okay, there's no C value. What else? It's negative. I got a negative in front of the x squared. That's going to be a problem because if I write this as a negative x squared plus 4x, that's a problem because x times x is x squared. Like negative x squared is not a perfect square, is it? No. So what I'm going to actually start doing is I'm going to write this down with a negative factored out. So suppose I factor out a negative. What are you left with? Great. Now I can complete the square. What number do you add to complete the square? 4. So I'm going to add 4, but I will not subtract 4. Again, this is the point you guys have to focus on because I know I told you, like if you add 4, you subtract 4, right? That's what I said. Folks, that's not actually a positive 4. It's a... See how it's negative 4? So I add 4. Okay, we need to maintain a net change of 0. So if you look at this one right here, notice how we had a +9 and a -9. That makes 0, right? Well, in this situation, okay, I have to add 4 and I have a -4. That makes 0. Do you see that? So I have to consider the true value of this 4. This is not a 4, it's a -4. So I add 4. All right, great. So now I've got negative parentheses. What? X minus 2 quantity squared plus 4. Great. So what's the vertex? 2, 4. The negative does not change the vertex. The negative simply creates a vertical flip. Yeah, exactly. So I've got a vertex of 2, 4. So we go over 2 and up 4. Up or down? There's my shape. So does that have a maximum value or a minimum value? Has a maximum value of 4. Yeah. Not too bad? Okay. So then, my last problem, what makes this different?
The 2's on.
The 2 in front. And that's not going to create a perfect square option for us, is it? Not divide by 2, but we factor out the 2, right? Factor out the 2. So I'm going to write this as f of x is equal to, and if I factor out 2, what are you left with? Yeah, good. 3 over 2x. And then I'm actually going to put the -1 outside the factored spot. Now, Izzy's saying to herself right now, Mr. Gantz, you just making math up right now because is that even legal, right? Yeah, anybody else feeling that way? Like Mr. Gantz just feels like you're making stuff up right now. Gotcha, okay, gotcha, okay? I'm right there with you. So here's what I want you to do. Anytime you're wondering, is this the same as that? Then just go ahead and try to bring it back to that form. What's 2 times x squared? What's 2 times -3 x? -3x, and then I have a -1. So it is the same. It really is. I just chose to put it there. I only want to factor something out of that. Okay, only one factor. And if you're like, well, Mr. Again, since when can you factor something out of just one part? We've done that plenty of times before, haven't we? Like if you have x cubed minus 4x squared plus 3y minus 3, what can you factor out of here? X squared, and you get x minus 4, but that doesn't mean that you factor it out of this, do you? Here you factor out a 3. So sometimes we factor by parts, do we not? Yeah, exactly. So it's okay to do that. So I've got that. All right, let's complete the square. So I've got to take this, and this gets difficult because we have fractions. I take 3 halves and divide it by what? 2. What's 3 halves divided by 2? 3/4, because you multiply by the reciprocal. Yep, you get 3/4. Good. And then what's 3/4 squared? 9/16. So I've got 9/16 here. Now this does not have a true value of 9/16. It has a true value of 18/16. What is 18/16? 9/8. So I've really just added 9/8. So if I added 9/8, then I should subtract 9/8. Good. So we've got that set up appropriately. You can see when you have a fraction how it gets kind of challenging. We have to deal with fractions. If we don't, we forget what to do with them. F of x is equal to 2 times x what? Three over 4 minus, and then this -1 is a -8/8, right? Yeah, so if you have -8/8 and you subtract 9/8, you get -17/8. Okay? It's kind of ugly, isn't it? Yeah. But, you know, we are college algebra students, and so we should work with fractions, right? Should be something we can do. So we've got a vertex of what? Yeah, and so this is like 0.75 and then -17/8. That's a -2.125. So I'm going to plot that. So I go 3/4 over, and I go down 2.125. And is it up or down? It's up. Has a minimum of what? Maybe 2.125 or 17/8, however you want to write it. And that's that. Sir.
Would it be okay if you rounded the decimal to like -2.113?
Sure, I'd accept that. Can we do this?
Sure.
Okay, so what I want you to do is I just handed you a new homework packet, right? So my good friend Caitlin, okay, she's got her stuff all ready to go. So what she could eventually do is take this sheet, which is on parabolas in standard form, and she could rip off this cover sheet and put the standard form one right there. You know what I mean? And then restaple it. Or if you'd like to staple it to the back, I don't care. You guys do whatever you want. But get that back in there. We all good? Yep. All right. So parabolas in vertex form, if you guys look at the sheet, please. Actually, I could bring that up, I suppose. Look at all the Word documents I got. Yeah, been busy today. All right, so I want to be clear about what I'm going to be asking you to do on the test. Here, you'll be changing it from standard form into vertex form. Okay, so I want to see your work, and then you would actually write the vertex form like y equals x minus 1 quantity squared plus 3 or something. Then identify the vertex and the direction in the graph, okay? But so that should hopefully explain what I'm looking for there from you, okay? So only about 6 minutes, but see if you can get 1 or 2 of them done so you can at least get it on your brain. I'm going to come and answer 3 questions for help right now.